Alright guys, here's our review for Unit 5, Test 2. So the first 4 problems are all about factoring. So the first one, it's already factored for us. So remember, if this times this is equal to 0, I'm going to set them both equal to 0. And then I'm going to solve them for x. So for the first one, I add 2 to both sides. 4x is equal to 2, dividing by 4. X is equal to reducing 2 divided by 4, that would be 1/2. For the second one, I'm going to subtract 8 from both sides, and so I get 2x is equal to -8. Dividing by 2, my second solution is x is equal to -4. For number 2, I want to set it equal to 0 first, so I'm going to subtract the 10a from both sides. And then a squared minus 10a is equal to 0. And then I'm going to factor out the GCF. Common to both a squared and 10a is a, and I've got a minus 10 left over. And then I'm going to set them both equal to 0. So either a equals 0 or a minus 10 equals 0. And then to solve this one for a, I would add 10 to both sides. So my two solutions are 10 and 0. Number 3, again, I need to set it equal to 0 first, so I'm going to add 65 to both sides. Got b squared minus 18b plus 65 is equal to 0. Factoring that guy, I'm looking for a number that multiplies to 65, adds up to -18b. And that would be 13 and 5. Since it's -18, I need both of these guys to be negative. I can't make that one negative. And so I get b plus 13, b minus 5. And so setting those both equal to 0, I get b plus 13 equals 0, which means b is equal to -13. And b minus 5 equals 0, so b is equal to 5. All right, number 2, I'm going to move everything over this way. So I've got 2x squared plus 9x minus 11 is equal to 0. Then we're going to factor it. So I've got 2 times 11 is -22x squared. And that needs to be 9. So I'm looking for 2 numbers that subtract, because this guy's negative, so negative and positive. Subtract to 9, multiply to -22. So that'd be 11 and 2. So I need 11 to be positive because 9 is positive. So 11x minus 2x gives me my 9x. And now during my little factoring box, my first term is 2x squared, last term is -11. And I've got -2x and 11x. So what's common here is just x. X times 2x gives me 2x squared. X times 11 gives me 11x. 2x times -1 would give me -2x. -1 times 11 is -11. So now I get 2x plus 11 times x minus 1. And then I'm going to split both of those guys up, set them both equal to 0. So here 2x would be equal to -11. And then dividing by 2, x is equal to -11/2. That's one answer. Over here, I'm going to add 1 to both sides. So x is equal to 1. All right, that's 1 through 4. Moving on to section 2. We've got a graph. We need to find all of these features of it. So the vertex, that's your highest point or your lowest point. So that's going to be up here. That's when x is 1 and y is 9. Since it is the top of my parabola, it's going to be a maximum. My axis of symmetry cuts my parabola in half. And so that crosses the x-axis at 1. My x-intercepts are going to be -2 and 4. So -2, 0, and 4, 0. My y-intercept is 0, 8. Domain for any quadratic is between -infinity and +infinity. And then my range, remember this guy is going down to negative infinity, and that the highest y value is 9. So the lowest y value is negative infinity, we're talking about y's, and my highest y value that we're going through is 9. All right, Johnny and Tim. Oh, that looks very pretty, but that's not what it's supposed to look like. I need a graph here. I'm going to have to come back to that one. All right, number 3, it says given the zeros, write an equation for the quadratic function. So here's a 0. So I've got 1, 0 at negative 4, 0, and 1, 0 at 2, 0. And then remember, when you write the equation and you put it in quadratic form, it's where you're going to change those signs. Because now we're going from solutions back to the factor. So one factor would be x plus 4. The other factor is going to be x minus 2. All right, same thing for number 8. My factors are negative 1 and positive 2. So my function is going to be x plus 1 and x minus 2. For number 9, I don't have a graph, but they gave me the zeros. So my equation is going to be y. Remember, y and f of x, same thing. You can do either one. This would be x plus 5 times x minus 7. All right, that's it for 7, 8, and 9. Number 10 requires a calculator, so we'll come back to that one as well. Probably in my next video, we'll hit those table ones. All right, given these tables in number 12, find the zeros, axis of symmetry, vertex, and then write an equation for the function. All right, so first thing they want us to find is the vertex. So remember, for the vertex, we're looking at our y values, and we're trying to find where's the middle of this graph. So 0, negative 5, negative 8, negative 9, negative 8. I start going back up, and these guys start being symmetrical around that negative 9. So this is the one in the middle. My vertex is negative 1, negative 9. My axis of symmetry is always going to be x equals the x value of the vertex, which is negative 1. My zeros, that's when y is equal to 0. So my zeros are negative 4, 0, and 2, 0. So to write my equation, I'm going to change these zeros into factors by changing the sign. So I've got x plus 4, x minus 2. All right, number 13. Again, looking for that place where it gets symmetrical. So I've got negative 5, 0, 3, 4, 3, 0. So I see it here, 4, 3, 3, 0, 0. That's my highest point right there. So my vertex is 5, 4, which means my axis of symmetry is always going to be x equals that x value of my vertex, so x equals 5. My zeros are 3, 0, and 7, 0. And then to write the equation, I'm going to change these guys into factors by changing the sign. So x minus 3, x minus 7. All right. Number 14, we've got a transformation table. So we've got some equations. We want to see if they have a vertical stretch of compression. So looking for a vertical stretch of compression, remember, we're looking for a number out front. And if the number is bigger than 1, it's a stretch. If it's less than 1, it's a compression. So here I have 2, which is bigger than 1, so it's a stretch. For 15, there's not a number out front, so there is no vertical stretch of compression. Same thing with 16, there's a negative sign, which we'll talk about in just a second, but there's not a number, so there's not a stretch of compression. And for 17, the number out front is a fraction less than 1, so it's a compression. All right, for a reflection over the x-axis, we have to have a negative sign out front. So here, we don't have one. It's a none. Number 15 doesn't have one. It's a none. Number 16 does have that negative sign, so this is a reflection. And 17 does not have one, so no reflection. All right. Vertical translation, remember that's the same thing as a vertical shift. So our vertical shift, we're looking out behind the x squared to see if there's anything back